let's start and let's see what the question is asking us. It's on the screen. We are given, we're supposed to prove that this expression that I've got here is equal to b root a minus 1. Now, folks, look at the marks. It's for 4 marks. So it should be a quick answer that you can get to. So that's the answer. It's not an equation. It's asking us to prove that this is equal to b root a minus 1. Now, let's see. What do I have hidden on my left-hand side? I have 2 exponential rules. One is an exponential rule or surd rule. The other one is an algebra rule. The first one is if I take the square root of a, let me write this down. If I take the square root of, let's call it p, and I multiply it with the root of q, if the root type is the same here. So let's say the nth root and the nth root. In the case of the square root, that's a 2. If I have this product, I can sort of just write all of it under one root. Then if we look carefully, so this is the situation there. It's the square root of something multiplied by the square root of something else. So that's the first thing we're going to do. We're going to combine it in a root. So I'm going to write these things in brackets for ourselves because every single one consists of 2 terms. Okay, so 2 terms in here, 2 terms in there. Now, the second law that is hidden here is if I look at m, if I let this be m, and that be m, and this be n, then that will be n. So I have m minus n multiplied by m plus n, which we all know is m squared minus n squared. Okay, so my very first step here was to bring these 2 under the same root. Okay, b root a plus b. And now I'm going to apply the blue components. I'm going to write it in blue. Okay, it's the first term, b root a, all squared, minus the second term, all squared. The difference of 2 squares. Now, folks, remember, if you square a square root, the root disappears. Like if you cube a cube root, the root is gone. So the case here, I'm squaring the square root. Okay, so finally, I'm going to get b squared under the root, b squared multiplied by a minus b squared is just b squared. Now I can remove the b squared as common, and I know, now this is a definition, that the square root of this b squared is going to give me a b. Okay, so if I square root that and I remove it from the root, I have b root a minus 1. A quick 4 marks to start a nice, it was question 2.2 in this paper, but it's a lovely algebraic start to wherever this paper comes from. Now, folks, the interesting question is the second one. Look at this. They tell us that 3 to the a is 21 to the power of b, and 7 to the power of a is equal to 21 to the power of b. They want us to show that b is ac divided by a plus c, and clearly they have to tell us that a plus c cannot be naught. Now, look at the mark allocation over there. This question is very, very interesting because there's serious mathematics that you can apply to this question. You can also just use your common sense and do it in 2 or 3 steps. A friend of mine, Julian, and myself were looking at this today, and we thought, wow, for 5 marks, we are off track. We're going far too long with this question. And we thought a bit, and this is what we came up with at the end of the day. Okay, so there's the question. The 2 equations is given to you. They're asking us to show here, let me just go back there, to show that b is equal to a times c over a plus c. Now, folks, if you look carefully, you can see where the A is. The A is in the power, the B is in a power, the C is in a power, and so is the B. Okay, so all of those things need to be released from those bases. Okay, the bases are holding them captive. Okay, so we got to get that out of the way. The bases need to go. Okay, so let's see how we do that. The only way, now what's interesting here, and I'm sure Naya, you would agree with me, was the fact that these two things are the same. So indirectly, it's telling us that P is equal to Q and Q is equal to R, therefore P is equal to R. That's the one thing that comes to mind. So I can use the fact that 3 to the A is equal to 7 to the power of C if I want to. Another way to get to those powers, because these bases are clearly different, is to apply logs and log laws if you want to. Okay, you don't have to. Here's the beauty of this question. This is why it is for 5 marks. Let's have a look. I know, the first thing I know that's true here is that 3 to the power of A, I'm going to use that. I'm going to use 3 to the power of A is equal to 21 to the power of B. And the only way I can get this B out of that power is if somehow this becomes a 21 along the line. Okay? Then the bases are the same and I can drop my bases. But now that would mean I have to multiply with a 7, but a 7 to the power of A. Because if I want to connect those two together, then the powers need to be the same. You saw that happening earlier on with the surds. The same thing applies here. So we're going to take a different route. We're going to say, okay, let's raise both sides by the power 1 over A in this one. And in here, in the next one, 7 to the power C, which is also 21 to the power B, we're going to do exactly the same. But this time round, we're going to raise it to the power 1 over C, both sides. What you do to one side, you need to do to the other. So we get to 3, which is equal to 21 to the power B over A. And here, I get 7, which is equal to 21 to the power of B over C. Remember your exponential rule that says A to the power M to the power N is the product of those two powers, grade 12s and grade 11s that are possibly watching today. Remember, okay, if I multiply two bases together and the bases are like, I add their powers. Here, I want to multiply the powers and not the bases, so I need to raise to the power. Okay, so let's continue and let's see where this gets us. Now, if I now take this 3 and I times it with that 7, if I now go, I'm going to change the color. 3 multiplied by 7. Okay, then what does that give me? That gives me a 21. Now, what is that? Well, it is this 21 to the B over A that's multiplied by 21 to the power of B over C. And over here, I'm multiplying like bases. So that's the rule we just mentioned. So we get B over A plus B over C. Now, folks, remember this is 21 to the power of 1. 3 times 7, nothing has changed there. It's still 21, like it's been billions of years ago. Okay, so now my two bases are the same. And I can drop the bases. I didn't look at a log here. And I can continue with my powers. That's clever. Okay, so we get 1, which is equal to, that's B over A, plus B over C. Now, if I times both sides, remember to do this as quick as you can, you multiply with the LCD on both sides of your equation. Okay, so I'm timesing there. Then I get AC, which is equal to the A's cancel, BC plus BA. If I multiply there, the C's cancel, I have BA, of which I can remove the common factor of B. And then I have A plus C. So suddenly the question has gone from a matric question to a grade 8 algebra question where you just manipulate the A's, the B's, and the C's. Okay, all I need to do now is get B by itself, so I divide both sides by C plus A, and voila, there we have it. We've proved that that is indeed the case.